Our discussion on Young's double slit experiment into fourth video. So in the previous one we actually have found a few things. So the position of the nth bright fringe equal to dn lambda by d. Position of the nth bright fringe. Position of the nth dark fringe equal to d by d into 2n minus 1 into lambda. Okay, here central maximum n is 0, central maximum n 0, first bright fringe 1 and 2 and so on. Here the first dark fringe is equal to 1, second dark fringe you are supposed to substitute 2. So fringe width of the bright fringe equal to fringe width of the dark fringe, both are same, it is lambda d by d, where d is the distance between the sources and the screen, and this one d is the distance between the sources. For example, it's like this. This is S1 and S2. This distance is d, this distance is d. And what about this setup is completely immersed in water. When Young's double slit apparatus is completely immersed in water, here the water will be filling the space. In that case, we know that refractive index of a liquid equal to velocity in vacuum by velocity in the medium. So mu is equal to frequency into wavelength in vacuum divided by frequency into wavelength in the medium, because when light travels from one medium to another medium, frequency remains constant. Frequency is constant, wavelength changes. Wavelength changes. So here what you can do is, from this relation, you know, wavelength in a medium equal to wavelength in vacuum by refractive index. So what happens to the fringe width when you just immerse the entire setup in water or any other transparent liquid? The fringe width changes because the wavelength changes. Other d by d, these two does not change. So what happens to the fringe width? Fringe width in air is lambda d by d. Fringe width in the medium equal to lambda medium into d by d, dividing the second equation from the first equation, actually 2 by 1, you get beta medium by beta vacuum, let's call it beta vacuum, equal to lambda medium, and when you divide these two things common will be cancelled. This by this means lambda medium by lambda. So lambda medium by lambda is 1 by mu. Here lambda by lambda medium is mu, so lambda medium by lambda is 1 by mu. This is equal to 1 by mu. Hence beta medium equal to beta vacuum by mu. So when Young's double slit apparatus is immersed in a liquid, what will happen to the fringe width is 1 by mu. If they give you the value of fringe width, I mean refractive index 1.5 or something, fringe width in water or in a medium equal to fringe width in vacuum, whatever value you calculate this value using lambda d by d. After that, divide by refractive index. If it is water, it is actually 4 by 3. So it is 3/4 of fringe width in vacuum, or 3/4 of normal lambda d by d. So this one we calculate. The second one, so this is an important thing, just listen. So here if you have the sources and if you have an yellow source here, if you have an yellow source, you have a bright fringe, dark fringe, bright fringe, dark fringe, and so on like that. It will be formed on the screen. In place of yellow, if you use red color thing, so red color being wavelength, suppose if you choose yellow and red, so lambda of the yellow is like this, means lambda of the red is actually greater than that. So the bright fringe of this is actually not like this. So they will be asking which of the bright fringe coincides with which of the, which bright fringe of yellow is coinciding with which bright fringe of red. See, when you look here, 1, 2, 3, the third yellow is coinciding with the second red. So here the condition is, from the center, this point where it coincides, both are having the same y value, but the number of fringes are different. So you can use this formula, y is equal to position of the nth bright fringe equal to d lambda d by d into n, or I'll write like this itself. Position of the nth is d n lambda by d for the first wavelength and the second wavelength. So d n1 lambda 1 by d, which is exactly equal to d n2 lambda 2 by d. So in that case, when these two cancels, so it is n1 lambda 1 is equal to n2 lambda 2. So to produce, if ask is, if wavelength of let us say 2 lights are used, when they use a 500 angstrom wavelength, and let us say some 10th bright fringe coincides. If you use 700 angstrom wavelength, how many fringes are there in the same thing? So use n1 lambda 1 is equal to n2 lambda 2. We don't know this, let us find that out. So n1 is 10, wavelength 1 is 5000 angstrom, n2 we don't know which order that is coming in. So 10th bright fringe means 10th order, 20th bright fringe means 20th order. So n2 is 7000 angstrom. So these 3 and angstrom, this 3 and angstrom will be cancelled. 5 into 10, 500 divided by 7 is equal to n2. Like that we calculate things. Okay, so two things we have discussed today, like fringe width in a medium equal to fringe width in vacuum by refractive index. So when light waves are replaced by a different frequency, how many orders will be found within the same length? n1 lambda 1 is equal to n2 lambda 2. We'll continue our discussion even in the next video.